My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 219. In this lecture, we will try to understand data pre-processing, in which there is a topic known as feature normalization. We will try to understand this feature normalization. Imagine if I have a data matrix capital X like this. Let me assume this is my data matrix capital X equal to this one. I will repeat. Imagine if I have a data matrix capital X where each of my columns are features. How can I write? F1 feature 1, F2 feature 2, F3 feature 3. That may be petal length, petal width, sepal width, so on. Let me assume there are how many features? There are D features. Let me assume there are D features. And each of my points, let me say there are n points, x1, x2, so on, xi, so on, that is xn. Let me say there are n data points, even I have corresponding labels. What is my this labels? Yi, I can say this is my y. We already discussed what is label. This is y. Let me say this is yi. How many rows? This is my data matrix. We discussed about this data matrix. I'm not even looking at y, but let's just write y here. So here is my yi corresponding to xi, isn't it? That xi and yi, they are corresponding to each other. Yi is a class label. There is something called data pre-processing. We will try to understand what is data pre-processing. This capital X is my data set. Now, data pre-processing, the word pre-processing basically refers to some type of mathematical operation. What is this pre-processing? Pre-processing means data pre-processing. What is the meaning of pre-processing? It is some sort of mathematical, I can say it is mathematical operation. What is this mathematical operation? How it is useful? We will try to understand. I can say it is a mathematical operation and transformations that we have to do on the data itself. It is some sort of mathematical transformation. This transformation has to be performed on the data itself. Before we go and do other more complex data transformations, for example, we wanted to do dimensionality reduction. How will you do it? How dimensionality reduction to visualize data more efficiently, or even do before we build model. That's what I discussed in my previous lectures. Before visualizing data, just try to pre-process the data, or you must reduce the dimension, something like you have to perform dimensionality reduction, isn't it? That I already discussed. We do some pre-processing, basically means what type of operations do you perform before actually go and build the model. Before building the model, whatever the operations you are going to perform, that can be considered as pre-processing. I can say that is pre-processing. You obtain your data. First you have to do just obtain data. Just what will you do? Obtain your data. What is after obtaining? You obtain your data and then perform bunch of data pre-processing, bunch of pre-processing operations. After obtaining data, just perform some sort of pre-processing operations. What is this pre-processing operations? We will try to understand. First collect the data, then apply pre-processing operations. Depending on the problem, and then you do your modeling. First, so as a part of pre-processing, there are multiple operations. One of them is called column normalization. I can say first you have to obtain data, apply pre-processing, and you have to build the model. You have to build the model. That's a procedure modeling. What is this? We will try to understand. What is this procedure? We will try to understand. There are, as I told you, as a part of pre-processing, data pre-processing, there are multiple operations. One of them is column normalization. You must understand this column normalization comes under data pre-processing. Whether you do column normalization or not, there are many types of data pre-processing techniques. Again, it's very problem specific. As I told you, this column normalization comes under data pre-processing, but these data pre-processing techniques are problem specific, domain specific. I can say problem specific. Different problems may have different pre-processing techniques. We learn about some of the most important data pre-processing techniques as in when they are important. So before we go and do dimensionality reduction, what you have to do, I will explain. We will take one. We will try to understand. Before we go and do dimensionality reduction, we have to pre-process our data so that it's in a form that must easier for the dimensional reduction algorithms to use. One such operation is column normalization. After performing column normalization, if you apply dimensionality reduction technique, that will be the efficient way of doing things. So you obtain your data, you pre-process your data. First obtain data, then pre-process your data before you go and do the data modeling. Before building the modeling, just pre-process the data modeling in a nice format. Your data is neatly formatted in such a way, or neatly processed in such a way of data modeling algorithms can perform good. Your data, if you want your data modeling algorithms performance to be good, just apply pre-processing before applying the data. One such operation is called column normalization. This column normalization is a data pre-processing technique. After performing this pre-processing technique, if you build the model, that model works more efficiently. Let me explain what is column normalization. I have my features. We will try to understand what is our column normalization. I have my features. F1 is a feature, F2 is a feature, F3 is a feature. There are how many features? There are D features as a columns. Let's say how many features there are, D features, and how many data points, 1, 2, I, so on, n. There are n data points. Each data point corresponds to each data point have its corresponding label. I can say this one is xi whole transpose, as xi is a column vector, xi whole transpose must be a row vector. It's not new thing which we discussed this one long back. When I will do column normalization, let me explain what is column normalization, what is its important. We will try to understand. I will quickly explain why it is important. First, what is column normalization, what it means. First we will try to understand what is column normalization. You take each column, otherwise I will rewrite this one. Let me rewrite, maybe I will rewrite this one like this. How can I do it? Just see, you take each column. Let me rewrite this particular matrix. This is my matrix. Let me write this one as like this. Let me say what are the features. F1 is a feature, F2 is a feature, F3 is also feature, so on. Let me say there is a jth feature, Fj, so on. Let me say there is dth feature, that is Fd. How many data points do we have? 1, 2, f3, so on. I have ith data point, so on. My last data point is n. I can say, as this is ith data point, what is this? Xi whole transpose. This is Xi whole transpose. I already discussed this is Xi whole transpose is a row vector, and correspondingly I have labels, classes. Let me say this is Y. I can say this is Yi. This what is the order of this particular, how many rows? There are n rows and d columns. This is n by d. This is n by 1 column vector. I can say this we already discussed. Now these features are like your features, means these features can be in iris data set. We have seen that may be sepal length, sepal width, petal length, petal width. We always referring that particular data set. Just go through that data set once, just to refer your memory on what here these are the features. So you take all values corresponding to these features. You take all the let's assume I have values a1. Let me assume I have values a1, a2, so on an. These are the values, isn't it? A and a2. Let's assume this is my feature gene. Let me say this is fj is my feature gene. This is my feature. What are the values in this feature? Let me say a1 is first value, a2 is second value, a3 is third value, so on. Let me say this is ith value, this is ith value, so on. Let me say this is an. How many values are there? There are n values. Take I can say a1, a2, ai, so on. Let's assume this is my feature fj. Take a column. What I will do, I will transform all the points in this column. Just see what are the values in this column, a1 to so on an. I will transform. First I will process first column, then I will process second column, then I will process all the columns one after the other, isn't it? I can say we only process these. How many columns are there? There are d columns. We will process all these d columns or d features. I can say these are d columns or d features. That, as I told you, we process each column separately, but we process all the columns one after the other. You must understand, we will transform, we will process all the columns. Let's see. I will show you what way to do for one column of data. The same thing is done for all other columns. Just we will try to do for one column. The same procedure we will apply for all other columns. I have a1, a2, so on. An here, these are the values, isn't it? The n values of feature j, whose values of jth feature, isn't it? Because I have n data points. Every data point has a value corresponding to feature in our case. Let's assume in our case, if you recall, we had what is iris data set size? There are 150 rows. There are 50 rows for each category of flowers. There are 3 categories of flowers, 3 labels, isn't it? Now how many flowers are there? There are 150 flowers, and if I was using let's say petal length, I would petal length for all 150 flowers. Now I have these values a1, a2. Let me say fj is petal length. This is this is petal length. Which one is petal length? Fj is petal length. This column will give petal length of all 150 flowers. For example, f3 I can say sepal length. This particular column, f3 column, will give a sepal length of all the flowers, all 150 flowers. And if I say f2 is petal length, sepal width, this particular column will give all the sepal width of all 150 flowers, isn't it? In petal width, if I say this f1 is petal width, this particular column will have all petal width values of all 150 flowers. It's simple thing. Now I have these values. Let me say I have values a1, a2, a3, so on an. So first I will process them. Let's assume there is another column b1, b2, bi, so on bn. Let me say there is for another column. Let me say this is b1, this is b2, this is b3, so on. This is bi, this is so on. It is bn. For example, my F3 feature, if it is sepal length, if I assume this F3 is sepal length, I will get sepal length of all 150 flowers, isn't it? So let's see what I do here. Whatever do, let me explain with simple otherwise let me keep like this. Let me say like this. What is this value? Max of, let me write here, max of AI is equal to let me say A max. This is my A max. In similar manner, min of AI is equal to A min. That you must understand, isn't it? Max of AI means, in all AI means what? I equal to 1 to n. What is I ranges from I equal to 1 to n. It means in A1, A2, A3, AN, whichever is the maximum value, that is A max. In A1, A2, A3, so on AN, whichever is the minimum value, that is A min, isn't it? Because I can say, as A max is max of AIs, I can say A max is greater than or equal to AI, isn't it? A max is greater than or equal to AI. Even I can say A min is less than or equal to AI, isn't it? From I equal to, what can I say? From I equal to 1 to n. That must be the case. Your max is greater than or equal to all the values from A1 to AN, greater than or equal to, your min is less than or equal to AI, isn't it? Because I have n data points here. Just see, 1, 2, 3, so on I. How many data points are there? There are n data points here. These are the definitions of A max and A min. Just understand, A max is max of AI, A min is min of AI. Just we are defining what is A max, what is A min. Now let me transform this data. Which data? Otherwise let me rewrite it again. I am transforming this data. How can I transform? Just again let me redraw this particular matrix. Let me write it here. Just see this one. I will write here how many data points, 1, 2, 3, so on. I can say ith data point. This is nth data point. How many features I have? F1, F2, F3, so on, Fi, so on. I can say Fd. There are d features. And how can I say this Fj? Let me say this is Fj, and whose attribute value, this A1, A2, isn't it? A3, so on, An, isn't it? Let me say this is AI. This is something like Xi whole transpose. This is column vector. The Xi is column vector. Xi transpose is row vector. Let me say this is my capital Y. This is Yi. This order is, there are n rows and d columns, n by d. This is n by 1. For each Xi there is some Yi. Now as I will repeat, let me repeat this one. What is max of AI? That is essentially A max, isn't it? A max. What is min of AI? That is essentially, I can say it is A min, isn't it? Now I can say A max is greater than or equal to AI, and A min is greater than A min is less than or equal to AI for all I equal to 1 to n, isn't it? 1 to n. In this value, say in A1, A2, An, this A max is maximum value, A min is minimum value of these A1, A2, An. Your maximum value is greater than or equal to AI equal to 1 to n. Minimum value is this is simple and straightforward, because I have n data points. Just see, 1, 2, 3, so on, n data points. Here these are definitions of A max and A min. Now let me transform this data. Which data? A1, A2, A3, An. I am transforming this data is one column of the data. Let me say this is data D. Otherwise, let me say this is X. I will transform it as follows. Originally, I have points A1, A2, A3, so on, An. This will be transformed. How can I transform this one? Let me say this is number 1. Now I am transforming this into A1 will be transformed into A1 dash, A2 will be transformed into A2 dash, A3 will be transformed into A3 dash, An will be transformed into An dash. Let me say this is second equation. We have to create new data vector. How do I create any of this vector? Ai dash. My formula is simple. Ai dash. Ai dash is nothing but Ai minus A min. Ai minus A min by A max minus A min. This is simple formula, isn't it? This Ai dash, this Ai dash is always belongs to closed interval 0 comma 1. Just I am transforming by doing this transformation. Which transformation? Ai dash equal to Ai minus A min by A max minus A min. By doing this transformation, see these numbers A1, A2, A3, so on An, these numbers A1, A2, A3 could be anything. That A1, A2, A3, A and B could be anything. This may be 1.2, this may be 1.3, this may be 1.4, this may be 1.9, this may be 1.7, whatever it may be. All these values, any number, that may be any, it does not matter, any number, it does not matter to me. It would be any real number as long as the real numbers are integers. These numbers I can transform by applying this formula. Which formula? A dash equal to Ai minus A min by A max minus A min. I can transform them by applying this formula, such that my Ai dash is lies between your Ai dash is lies between 0 and 1. You can easily see this with this formula, right? Even if you want, just let me check what is Ai dash for minimum value, otherwise for maximum value. Just let me transform Ai equal to, in the place of Ai, I will substitute A max. Means I am interested in transforming A max by using this formula. What will I get? I will get Ai dash equal to, I am transforming A max. Therefore, in the place of Ai, I am transforming, in the place of Ai, I must keep A max. Therefore, A max minus A min by A max minus A min. What is this value? This value is 1. Means if you transform A max, you are getting 1. If you transform A min, what will I get? Just see Ai equal to, I am transforming A min. How can I transform? What is the formula? My formula says Ai dash equal to, in the place of Ai, I can write A min, isn't it? A min minus, I can write A min minus A min by A max minus A min. Means what will you get? You will get this one as A min minus A min means 0. Means at maximum, I can say you are getting, which one you are getting? If you are getting values in between 0 and 1, isn't it? You are getting values 0 and 1. For this A, I can say this A min, if this A min is translated into 0, whereas A max is translated into 1. Take any value from A min to A max, transform, just apply this formula. What is my formula? Just apply this formula. My formula is Ai dash equal to Ai minus A min by A max minus A min. Apply this formula, and if you apply this minimum value, if you transform A min, you will get 0. If you transform A max is 1. Means always all the values you will get in between 0 and 1. So that I can say A min whole dash is equal to what you are getting, 0. A max whole dash I am getting as 1. Just now we proved it. It's simple. So minimum value is 0, maximum. For minimum value of Ai, A min dash is equal to 0. For maximum value of A max dash equal to 1. For all other values, you will get Ai's is always lies in between 0 and 1. Given any feature vector containing A1, A2, so on AD, this Ai belongs to real number system. This will be if you apply which normalization, if you apply column normalization, what will you get? If you apply column normalization, I will get for A1 I will get A1 dash, for A2 I will get A2 dash, so on. For AD I will get AD dash, isn't it? AD dash. All these are belongs to closed interval 0 comma 1. All values lies in between 0 and 1. Well, it's understand why are we doing this? Why do column normal, why are we doing this column normalization? So that all values will comes in between 0 and 1. Suppose I am collecting heights and weights as follows. Let me say like this. I'm collecting heights and weights as two features. Suppose my first feature is height. Yes, let me say my first feature is height, and my second feature F2 is weight. Let me assume these are two my features. In which scale I am collecting my heights? I can say I am calculating. Let me say this F1, and I have another feature F2, isn't it? There is a table. Therefore, what will I do here? The feature 1 162 centimeters. Feature 2, that is weight, is having 52 kgs, isn't it? Something like this. This is 172 centimeters, whose kgs weight is 72 kgs. 182 centimeters, whose weight is 84 kgs. 150 centimeters, whose weight is 50. Let me assume some values. This is in centimeters. Let me say this one is in kgs. Height is in centimeters, weight is in kgs. I am calculating weights and heights of students. Let me say this is student 1. Let me say this is student 1. This is student 2. In that manner, isn't it? Student 2 like that. Student 2, something like that. If I put each of them as data point, what is my first data point? 162 comma 52. This is my first data point. If I put each of them as data point, one of them is in centimeters. This is in centimeters, isn't it? One of them is in centimeters, and one of them, another, this is in kgs, isn't it? 162 centimeters and 52 kgs. What is somebody collected this data instead of kgs, if somebody collected this data in pounds, isn't it? This would, if somebody collected this data in pounds, what happens? This would be roughly double, isn't it? This would be roughly double. What if instead of people collected, instead of collecting data in centimeters, if someone is collected in meters, what happens? It will change. If someone may collect this data in feet, isn't it? Someone may collect this data in lbs. It depends on situation, isn't it? I collect in feet or in meters, because real world variables can have many ways of collecting data. So we are saying that whatever way the data is collected, 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 means that may be centimeters, that may be meters, that may be feet in the case of heights, in the case of weights, that may be kgs, this may be pounds, that may be lb, something like that. I want all these values. I want so from here I am going to space through column normalization. I need feature normalization or column normalization. I am creating my feature 1 dash, f1 dash. This is which is feature 1 dash means that is height dash. I can say f1 dash means that is especially h dash. I am transforming this h, isn't it, in such a way that all the values for each student, all the values, these heights, I am going to transform feature 1 so that all the values lies in between 0 and 1. That's my idea. Similarly, all the values feature 2, whatever the values, this weights may be collected kgs, pounds, lbs. I don't care. I will transform all the values in between 0 to 1, isn't it? Whether they are collected in centimeters, meters, whether they collect meters or feet. I don't care whether your feature 1 is collected centimeters, meters, feet. I don't care. Just I will transform all of them in values in between 0 and 1. In similar manner, I don't care whether weight is collected in kgs, pounds, lbs. Just I will transform them into closed interval 0, 1. That is known as I can say otherwise I will write it. I will write this feature 1 is transformed only in between 0 and 1. Feature 2 is always transformed only in between 0 and 1. This is one type of data. I must say this is column normalization. I can say this is one type of I can say this is actually it's called data normalization or feature normalization or column normalization, isn't it? I can say this is one form of transforming your data such that the scale is independent. So both of them are in the same range. You are making independent of the scale, independent of whether centimeters, kgs, meters, pounds. You are transforming only in between 0 and 1. We are getting rid of scale. Yes, idea is this one. We are getting rid of scale. That's the basic idea. Yes, why are we doing all these things? Means idea is simple. Getting rid of scale. Getting rid of scale means as you are transforming every value in between 0 and 1, it must be independent of the scale, isn't it? Getting rid of scale and putting everything in the same scale. That is the idea. Putting everything in the same scale. In the same scale. That's the idea. That's the idea behind this feature normalization. You are putting all your features in the same scale, right? So scale actually can create a problem when we learn about regression and when we learn about classification techniques. We will understand why this is extremely important by having your variables in different scales. While performing classification tasks, regression tasks, your variables may be your dependent, independent variables, maybe your variables. I can say your input features. I can say your input features. Your independent variables, your input features, I can say your variables may be in different scales, isn't it? Could be in different scale. That's dangerous, isn't it? Your variables in different scales could be dangerous. If they are in different scale, it's dangerous. By putting everything in the same scale of the value, if you put them in the same scale, so that you can apply your classification task and your regression task, will be an efficient way of doing things. Means scaling means in this case feature normalization, as we are transforming all the values only in between 0 and 1. It's a much easy. There is one you must understand here. I can say like this. Let's understand geometrically same concept. We will try to understand geometrically. How can I understand these things geometrically? It's simple and straightforward technique. Just see this one. Let me assume here I have F1. F1 means feature 1. This is F1. This is heights. Let me say heights. This feature 2. Let me say weights. Let me assume F1 is heights and my F2 is weights. I can represent each person as data point in this. Let's assume first person here. Let me assume this is first person. I will represent each person with a cross. Let me represent all these persons with a cross. Let me say like this. I am representing each cross or with some cross or circle. So let's assume all my people are here. Of course, as you would know, as heights increasing, just see, as heights increases, weights also increasing. Just see. Your heights, as heights is increasing, your weights also increasing. We know that for most of humans, of course, for this point, let me say this is something like 170 centimeters. This is my height. Correspondingly, let me say this is 65 kgs. This is weight, isn't it? 170 centimeter, and the corresponding weight could be 65 kgs. Now, by doing transformation, by doing column normalization, by doing what feature normalization or column normalization, what we have to do, what we are doing, we are transforming every value in between 0 and geometrically. I want to explain it geometrically. I'm creating I'm transforming this data as follows. My h height h is transformed into h dash, and your w weight is transformed into w dash, so that h dash and w dash must be in between 0 and 1. The same concept I want to explain geometrically. What I am doing here, I am transforming each of these points on x-axis and y-axis to lie between 0 and 1, isn't it, Jesse? To lie between 0 and 1. So literally what I am doing here is I am creating a bounding box. Let's assume this is 0. Let me say this one is 0. Let's assume this is the bounding box. Let's assume this is 0, and this is, what is this? This is, I can say as this is 1, isn't it? This is 1. This is also 1, isn't it? Why? Because you are transforming values in between 0 and 1, and I will bring all these points within this region. As I know that formula, all these points I will bring in this region, only in this bounding box within this region. I am basically literally bringing all of these points. Basically I am taking this data, I am taking this particular data, I am taking this data, and I am squishing this data without spoiling the relationship. I'm transforming this data. I'm transforming this data. I'm squishing this data in the range in between 0 and 1 without spoiling the relationship. That is important. Without spoiling the relationship. This is unit square, isn't it? Maximum value 1, minimum value is 0. I'm squishing all of this data and bringing it onto a square. This is called unit square. This particular square is known as, I can call it as unit square because it's a square of side 1. This is length 1. This is length and width is 1. So this is called a unit square. So this is two-dimensional space. What happens if you do it in 3-dimensional space? What happens if I have data of like this? If I have data of this type, let me say this is feature 1, this is feature 1, let me say this is feature 2, let me say this is feature 3. In the case of 3 dimensions, I will construct what one can construct. I can construct a unit cube, isn't it? By applying this transformation, all these points will go into, this is unit cube. I can transform all this. Just it's an extension of 2D, as we did in two-dimensional unit square you are getting. In the case of 3 dimensions, you can transform into 3D. This is a simple concept. This is known as column normalization. This is known as feature normalization. What is the basic advantage of this one is you can get rid of the scale. Isn't it? That is the basic idea. That's some basic motivation behind it. So column normalization will take the data and put all of the data in the unit cube. That here it is taking all the data and keeping in unit cube. In the case of 2-dimensional, it is keeping in unit square, unit hypercube in same n-dimensional space. So it will keep in unit hypercube. Actually, it's literally squishing all of those data into a unit cube or unit hypercuboid. So unit cube, I can say. See why this is useful. Please bear with me. So at least one thing that you understand, this we are getting rid of scales. We are getting rid of whether the data is in centimeters, meters or feet for heights, whether the data is kilograms, lbs, pounds in the case of weights. You are getting rid of the scale. You are getting rid of the scales and getting everything into the same format. This is useful. We will see later. We will see why this is useful when we learn lot of machine learning algorithms or data science algorithms. And this data normalization or column normalization is an extremely important task that will perform over and over again through all of our modeling techniques. So we also understand the geometric interpretation of data normalization. In the next lecture, we will try to understand data standardization. This data standardization, which is similar operation to column normalization, but slightly different, we will try to understand. Just go through this lecture. If you have any difficulty, just keep a comment. Thank you very much.